Greetings to all those who have tuned in to this session. The purpose of the session is to unpack the paper that was set in 2025 at the team competitions organized by the South African Mathematics Foundation. The team competitions involve individual and team papers, and for both junior and the senior. In this particular session, we will be doing the junior team paper. The team paper has got 10 questions, and the full team of 10 tackle these problems together. So with those few words, we have other team competitions like this: junior 2023, junior 2024, and this particular one is junior 2025. So let's go straight to okay, so let's get this right. Okay, so here we are. 2025 junior team. Go on to problem, the very first problem. The first problem says there are 3 aircraft fueled at an airport. Okay, so you've got 3 aeroplanes. Not aeroplanes, aircraft, whatever they are. So they are at a particular airport. The smallest aircraft can fly for exactly 2 hours before it must return to base to refuel. So you got the small guy. He goes, takes him 2 hours, then he comes back to base. It takes him 1 hour to refuel, and then he goes again. So he keeps going round and round like that. That's the smallest one. The medium-sized aircraft can fly for 13 hours. So this guy flies for a longer period of time, 13 hours. And again, he also returns to the base to refuel. Okay, and then finally the same, the very large one. It travels for 19 hours without having to refuel, and then it comes back to base. Now, each aircraft takes exactly 1 hour to refuel. So it comes back, spends 1 hour, goes out again. So these planes go up and down, and they just give themselves enough time to refuel. Okay, so what's the question? Initially, all 3 aircraft leave the airport at 8 a.m. So all of them leave at the same time. Assume that this cycle of flying and refueling repeats continuously without delay. At what time will all 3 aircraft land next at the same time? Okay, so let's just analyze what's going on here. So let's have a look at this. It's the small aircraft. They all start together, and the question is now, at what time will they all land at base at the same time. This is base, the starting point. Okay, let's see now the small aircraft. Let's see at which times it lands at base. It starts from 0 after 2 hours, comes back to base. Then it puts petrol for 1 or gears or whatever, fueling, and then another 2. So it takes another 3 hours before it can land at base. So after 5 hours, it lands at base again, and then again another 3 hours. So it keeps coming back to the base after every 3 hours. This is small. As far as the medium is concerned, that guy, he comes to the base after 13 hours, as you can see. And then the next time he fuels for 1 hour and 13 hours, he comes back to base after 14 hours. So it's 13 plus 14 is 27. And from here, it's another 14 hours to get back to base. So that makes 41, another 14, 55, and so on. And the large aircraft, in the same way, takes 19 hours to come back to base, and then 1 plus 19, 1 hour refueling, another 19 for the next trip. That makes 20. So 20 hours later, it comes back. 69, 89, and so on. And after every 20 hours, they come back. Now we want to see at which time do we have the same number occurring in all 3 sequences. And that'll be the first time that they will all be at base together. So let's see what these numbers are. These numbers here, you will see that it's after every 3 hours. So if you add 1 to all of these, they become a multiple of 3. 3, 6, 9, 12. So suppose they land at base after n hours. Suppose first landing of all 3 aircraft is after n hours. All right, now you can see that n must be here. In the very first case, small, you have to add 1 to get a multiple of 3. So it's 3 times something. Let's call it x plus 1. So here n is a multiple of 3. Okay, let's put it this way. N minus 1 is a multiple of 3. Right, so you can see, if you take this and, well, actually n plus 1. Two, 5, 8, and so on. So it's n plus 1 is a multiple of 3. This is how we write this for the small. For the medium, now you have to add 1 again. Now you get 14, 28, 42, and so on. So you see that when you add 1 to n, that's going to be a multiple of 14. Right? They all land at the same place after n hours. Okay, so if you add 1 to these numbers, you get a multiple of 14. And likewise, the large aircraft, if you add 1 to them, it becomes a multiple of 20. 20, 40. 59, 79. So if you add 1, it becomes a multiple of 20. So if you look at these three things here, what we are saying here is that n plus 1 is a common multiple of 3, 14, and 20. Right, because you can see n plus 1 is a multiple of each one of these, but you're looking for the smallest one. So we're looking for the least common multiple of 3, 14, and 20. And you learn how to work out the LCM of numbers in primary school. So if you work out the LCM of these, you see LCM is 420. And if you check it out, you'll see it's 420. Use whatever methods you like to work out the LCM. So that's n plus 1. So n plus 1, let me go here, n plus 1 is 420. It's the first time, smallest multiple of all three. So that means n is equal to 419. So after 419 hours, they all land, come back to base. Now this is hours. Okay, now you have to, this far more than 24 hours make a day. So you have to divide this by 24 to find out how many days there are. And you will see that 419 divided by 24 is actually 17 times 24 is 408, remainder 11. All right, so after 8 o'clock in the morning they leave, and every 24 hours, 11 days, 17 days later, they will all be back at base. 17 days and 11 hours later. So this represents the dates. So the actual time of arrival it's 8 hours, is 8 a.m. That's when they all started. 8 a.m. plus 11 hours. Yeah, because see, after 408 hours, if you take out 11 from here, they are all together at base. 419 hours at least. Okay, there's 7 days, 11 hours. So this means that this is 8 o'clock in the morning, you add 19, so it's 19 p.m. or 7 p.m. 8 plus 11 is 19, and then it's the same as 7 p.m. That's 11 hours after 8 o'clock in the morning. Okay, so that's the answer. It took a while to get to that answer. Let's get to the next problem. But before that, let's check I've got all the solutions written immediately after the questions. So they're just to help us along and at the same time give you an opportunity to spend more time looking at the solution. Okay, so I didn't really work this thing out. Oh, yeah, here we go. All right, so there it is. 19 hours or otherwise 7 p.m. Okay, so let's get on to question 2. Question 2 says a square is divided up into 4 identical smaller squares with side lengths 1. So each of these small squares has got side length 1. Like that. Now, circles are drawn inside 2 squares as shown in figure. Okay, these circles you can see are touching the sides of the square. And calculate the shortest distance between the 2 circles. All right, now what is the shortest distance? The shortest distance will be from here to here, it looks like, right? So it certainly looks as if we are going halfway in between. Okay, let's just do this. Suppose I take a diagonal of the square. Now the diagonal of a square will go through the center of the square, center of the circle. Actually, it goes to the center of the square, right? If I draw the other diagonal, this will be right at the center. Okay, so, and this point here will be the same distance from all the 4 boundaries of the circle, this point. From here to here, you can work out it's the height of this triangle. From here to here is the height of that triangle. And all these heights are the same because these 4 triangles are congruent. So therefore, when you draw the center, the circle, that will have radius 1 unit, half a unit. So this is actually a half from here to here. The whole thing is, the diameter is 1. If you join from here to here, if I join these points of contact, that will be the diameter. And that's 1. So therefore, the radius is a half. Hey, wait a minute. The circle is divided into 4 identical square units with lengths 1 unit. All right, this is right. Okay, so what do we have here now? Now, why did I do all this? I wanted to show you that these 3 points, they all lie on the same straight line. And likewise, these 3 points, because the center of this line here, this diagonal, is also the center of the circle. Okay, so if I join for the same reasons, this will also go through the center. Okay, so, and of course, this angle here is 45 degrees because in the small square, you've got the diagonal bisects the angle. Here in this small square, the diagonal bisects the angle. And the large square also the diagonal bisects the angle. So all this line here will be, the diagonal of the large square is also the diagonals of the 2 small squares. And that's an important observation. Okay, so what we need to do is to calculate the shortest distance between the 2 circles. That is what is asked. Now, the shortest distance is obviously that one. These 2 points are closest to each other. Every other point, you see, it curves upwards, get further away. So here, it's right on target. So we need to work out this distance here. So how do we work out the distance? Well, the way to do this is, it's quite a common practice. You complete the right angle triangle with the two centers. So you start with the center, go down to the middle of the square, and then join that. Then we can now work out the distance between the two centers. Okay, how do we do that? Well, this is half, and this is half, so this whole thing here is 1. And here too, you've got half, half, so it's 1. So we know the full length. Let's call it PQ. So we can see the PQ is the hypotenuse of a right angle triangle whose sides are 1 and 1. So it's square root of 1 plus 1, which is square root of 2. That's the whole thing. But I don't want that. I want this distance. That's very easy now, because all you have to do is from this one here, you take away the 1 radius, which is a half, and also this other radius, which is a half. And if you remove those 2 radii, then you've got this. There is the shortest distance between the 2 circles. Okay, so the whole thing is root 2, and you have to subtract the 2 halves. There's a half here, there's a half there. You have to remove that from root 2, and you get root 2 minus 1. So that is the shortest distance. Let's call it xy. The shortest distance is equal to xy. And that is square root of 2 minus 1. That's easy to calculate because you can use Pythagoras. All right, so that now takes me to problem number 3. Right, problem number 3. The question is to find the largest 4-digit number number such that when you reverse its digits, like 1, 2, 3, 4 becomes 4, 3, 2, 1, the new number minus the original number is 6,543. All right, I just want to move this thing. I don't know why I struggle to move this. Anyway, let me try to. No, okay, it's not going to work. All right. You want to look for the largest 4-digit number. So we don't know what that number is. It's got 4 digits. Let's call those digits A, B, C, D. Let A, B, C, D be the number. And this is a 4-digit number. This is not multiplication, A, B, C, D, B, D. Original 4-digit number. Right, okay. Now we reverse the digits. Is DCBA. All right, so I reverse the digits. The new number, DCBA, minus the original number, ABCD, is equal to 6543. All right, so we have an equation with 4 unknowns, and we are asked to find what those unknowns are. That's a nice thing about natural numbers, number theory. You don't need to have too much information. A lot of information is already contained in the fact that they are counting numbers. These are digits, actually. The digits are from numbers from 0 up to 9. Those are called digits. Okay, now the actual value of this is 1000D, take the place values, plus 100C, plus 10B, plus A. So that is the new number minus the original number. And the original number is that one, which is 1000A, this is 1000B, plus, I'm sorry, 100B, plus, we're looking at this number here, 10C plus D. So this is your new and the original. All right, now I'm going to subtract these two. When I subtract those two, I get 1000 into D minus A. Okay, so we're taking care of that. Here you've got plus 100 into, you got 100C minus 100B. So it's C minus B. And here you've got plus 10 into B minus C. You subtract those two, plus A minus D. Now this is equal to 6543. Because it's given that those two numbers, when you subtract them, 6543. But you've got 4 unknowns now. How are you going to solve? Right. Now you'll observe here that this is D minus A, this is A minus D here. So I can put a sign in front of D minus A, and it's the same as minus, this is the same as minus D plus A, or which is minus 1 into D minus A. So I'm going to get D minus A in both places. And likewise, I need to get B minus C in both places. So I can put minus 100. Or maybe we should do this. Make this a minus sign here. And then these two change. Instead of B minus C, I should have had C minus B. I'll put a minus sign in front. So you have minus 10 into B minus C. Or C minus B. All right, now you get 100 of D minus A minus 1 D minus A is 99 into D minus A, or 999. 1000 minus 1. And here you got C minus B is occurring in both places. So it's C minus B into 100 minus 10. Is that? So that is 6543. All right, now you still have to wonder how are we going to get to this answer? But you'll notice that when you add the digits here, you get 11, 15, 18, and 18 is a multiple of 9. So here you got multiples of 9 on both cases. So let's divide by 9 right throughout. It's 10 into C minus D, B. Divide by 9. 9 goes into 65 7 times, and it's 727. Okay, now you got 111 times something, and here you got 727. I can make this thing 777. That's a multiple of 111 minus 50, right? Now, this is a nice way of writing it because here you got a multiple of 10 and you got a multiple of 111. See, I made this, all the digits are made in the same. Okay, so you're going to subtract these two. So you really should have had a minus sign here also. So I have to put a minus sign in front, and then I have B minus C. Is equal to this. So from here, by inspection, you can see 777, 50. So you can see that D minus A, these are all digits. So D minus A is equal to, let me try to find some space here. So by inspection, you'll see that D minus A must be 7. 111 times 7 is 777. Here you got minus 10 times. So it's B minus C. Will have to be 5 because 10 times 5 is 50. Okay, now you got digits. But the question is find the largest 4-digit number. So you want to make D minus A, D minus A is, but you want to make D as large as possible. So you can have D equals A plus 7 from here. But the largest value of D is 9. So you can just make D equal to 9. And then A is equal to 2. All right. So you want the largest 4-digit number. So I want the A to be as large as possible. But you see that A is equal to 2. And once you do that, then you will see that B minus C is 5. Right? You can substitute, if you like, D minus A, 9 minus 2, and you get 777. That 777 goes away. Minus 10 times this, 50, so you got B minus C. It has to be 5. So again, we can say that B is equal to C plus 5. And B is the second digit. So you want that B to be as large as possible. We also saw that for A to be as large as possible, you'll have to have D equals A plus 7. And A to be, the largest value A can have is 2, because you want D to be a digit. In that case, D is 9. Right. In a similar case here, you'll see the B is a digit. So the value of C, the largest possible value for B, we need that, is 9. That's the largest possible value for B. And that occurs when C is 4. Okay, so we got the values of the digits of the number that we are seeking. See, we have to look carefully to see what the question is asking. The given information, it's the largest 4-digit number. So you have to make this D as large as possible, or A as large as possible. And you see the largest value for A, according to this, must be 2, because you want D to be a digit. Okay, so the number is right. It's A, B, C, D. That's the original number. And A was 2. B is 9. And B is 9. Then C is 9 minus 5. So it's 4. And finally, the value of A we saw will have to be A will have to be 2. I'm sorry, D. The largest value for D, it will be A was 2, so 2 plus 7 is 9. So that's the answer. 29. 29 or 24? I think it's 24. AB. Right? The value for B, 29. Sorry, 29. B is 9. So the answer is 2,949. Okay, let's just check to see whether we're on the right track here. Oh, there it is, 2949. That is the same as the answer that we got. Okay, so let's get on to the next problem.